Well, good morning, everyone. Welcome to today, November 13, SpaceGeekSpeak. Today we have two great speakers that are representing Climate Reality Project, Dave Hansen and Douglas Yazell. Both of them have been involved in space industry for a very long time. Great careers. Both of them are now retired from, Dave retired from NASA and Douglas retired from Honeywell. And now Dave Hansen is pursuing or continuing with his interest in electric vehicles and renewable energy. And in fact, right now he is on the way to the conference or a huge industry gathering in Austin. And Douglas is sharing his knowledge with our future engineers by being a math teacher at the Houston ISD. This year, he is a teacher at the Houston ISD Sterling Aviation Early College High School near Hobby Airport. Both of them are involved in volunteer in Climate Reality Project. To this day, since 2006, Climate Reality Project has trained tens of thousands of volunteers. And they are continuing gathering more and more supporters just because the cause is so important. And now for the presentation. Must we change? Can we change? Will we change? The human-induced climate crisis is here already. But quite a few people demonstrate that denial is not just a river in Egypt. United Nations Conference of the Parties, COP26, taking place right now in Paris, in Glasgow, is pretty much our last chance to respect the guardrail of 1.5 C. A prominent climate scientist, a Nobel Peace Prize winner, told AWA Houston section in our dinner meeting on November 3rd, 2015, then 1.5 C Celsius was in our rearview mirror because of the delayed effects of greenhouse gases already emitted. The 2015 Paris Climate Accords created the agreement to stay well below 2 Celsius, which with an aspiration to respect the guardrail of 1.5 Celsius. But the later report from the United Nations Intergovernmental Panel on Climate Change persuaded most nations, including those responsible for about 2/3 of current greenhouse gas emissions, that the guardrail must be respected. Douglas and Dave, we are welcoming you to SpaceGeekSpeak. Please continue with your presentation.
Thank you, Svetlana. Thank you. I will try sharing my desktop and going to the keynote presentation. So here we go. I'm on the first slide and I'll click on play. And Dave, you go ahead and take it away. Let's see. There we go.
There we go. All right. Yes, I always love this beautiful photo taken from space of the entire Earth floating in the blackness. And it really tells us how we are already on a spaceship. So we talk about building spacecraft and sending people into space, but we, the human race, is already on a spaceship. And of course, we must take care of our spaceship or else it will not serve the functions that we need it to. So I always love seeing this photo. And a number of folks like to make the comment that when our astronauts first went and landed on the moon, they discovered the most important thing wasn't something on the surface of the moon. The most important thing they discovered was the fact that what they had left behind was the most valuable thing. They left the Earth. And of course, they returned back to the Earth and told us about their experience. So next slide.
I'm clicking.
Okay, and when our astronauts and cosmonauts are in space, of course, they, at the altitude that they typically are in orbit around the Earth, they experience 16 sunrises and sunsets per day. So here we see one of those sunrises or sunsets. And the important thing from this photo is to see just how thin the atmosphere is. So our Earth, fortunately, has enough gravity to maintain an atmosphere, which makes the planet livable for people, animals, plants, insects, microbes. And the atmosphere, for a lot of people, since all of us basically live down at the bottom of the atmosphere on the surface of the Earth, is seemingly infinite. And in reality, it's not. It is very thin. We can't continue to just pour anything we want to into it. We have learned over the last few decades that the start of the Industrial Revolution has really changed the composition of the atmosphere. We've gone from well below 400 parts per million of CO2. Back pre-industrial was probably about 250, something like that. We are now over 400 parts per million. And although that sounds like a very small amount, and as far as based on comparing to the other constituents of the atmosphere, the CO2 is a very small amount, but it has a very strong effect on the heat trapping ability of the Earth's atmosphere. Now, we wouldn't want the Earth's atmosphere to not trap any heat. We would just have an ice ball Earth, but we have actually pushed it too far. And so now the world leaders have been meeting in Scotland to discuss what we can do to get the CO2 and the other greenhouse gases from continuing to increase. Because this atmosphere, as I say, as you can see in this photo, it's really very thin and delicate, and we do need to take care of it in the same way that a farmer needs to take care of plants. If you want a crop, you can't just plant and ignore. You've got to tend to your crop, and humanity needs to tend to the atmosphere. So Douglas, next, please. So, of course, there's lots of statistics, and there'll be some in these slides here. Here you can see the amount of, as they're terming it, warming pollution into that thin atmosphere. And this particular number is based on every 24 hours. And in fact, they use the expression here, treating it as an open sewer. So sewers are things that we're used to because they take away things that we don't want to have around us anymore, things that are not compatible with our civilization. And the Earth's atmosphere has nowhere else to go. Anything that we dump into it, treating it like an open sewer, it stays there. Now, certain chemicals break down over time. Methane is the second biggest global warming gas after CO2, carbon dioxide, and it does break down after a certain amount of time. So it doesn't last as long as the CO2 does. CO2 is such a stable molecule, it lasts for a long time. So the fact that we're spewing so much in every 24 hours, this number here is 152 million tons. And it's really kind of strange some ways to measure gases in tons, but that's the way they are measured. It just is a huge number, and it just, the CO2 goes to the atmosphere and basically stays there. It doesn't change over human lifetime scales of time. So next, Douglas, please. So here's a little bit more of the science. So that radiation that comes in from the sun, which of course we're all very thankful for, comes in, and we want a certain amount of it to go back out into space, and we want a certain amount of the heat to be trapped. And that ratio of what goes out again and what gets trapped is what is changed by this increase now to over 400 parts per million of CO2 and the other gases. So this graphic just kind of gives you an idea of what's happening. Next slide, please. So this one's kind of busy, but it really shows you a lot of the different things that are being affected by and affecting the Earth and its atmosphere. Thawing of permafrost, it's one of those things that's happening because of warming temperatures. And then the downstream effect of that is that more CO2 gets released. There's CO2 that is trapped in the frozen ground. Once it thaws, it goes into the atmosphere, compounding the problem. So the problem has increased much more rapidly than some of the scientists thought at first. And I won't go through all of them, but you can see here, landfills, they can often emit CO2. Oil production, of course, is big because you're taking the carbon that's been stored underground and now turning it into CO2 and releasing it into the atmosphere. And the same with the coal, carbon, and so on. So, next slide, please. So this chart really tells you a lot because it's talking about carbon. And as it says at the top, the largest source of global warming pollution is the burning of fossil fuels. So it's taking that carbon that has been sequestered by nature and returning it to the active biosphere and atmosphere. Next, please. Of course, what we're looking at is it's not just purely the CO2 in the atmosphere, but what are the effects? And we've seen the effects. Global surface temperature has been rising. There have been more forest fires around the earth, and etc. that we see, and these effects of these higher temperatures are being felt by humans and animals and plants now all around the globe. Next, please. So here, yeah, you can see the graphic is just talking about how, in the same way that the previous one, the temperature in the last number of years has gone up dramatically. It's really, there's no question that we are getting warmer temperatures now on the Earth. Next, please. So here is just the idea that heat is affecting people of all ages, particularly sensitive people, elderly people. When you've got too much of a good thing, too much of a warm temperature, it's just bad for humanity. Next, please. Now, of course, there's a lot of interaction between the atmosphere and the world's oceans. So more than half of the Earth's surface is covered in oceans. And so a lot of the heat, and in fact, a lot of the CO2 doesn't remain in the atmosphere, it goes into the ocean. So there's an exchange. Some goes in, some goes out. But as more has been emitted into the atmosphere, more has gone into the oceans. And the heat of the oceans, especially at the surface, has measurably increased over the last number of decades. Next, please. So one of the things, of course, that heat in the oceans drives is hurricanes. And particularly in our Houston area, the effects of hurricanes have been felt for as long as there have been people living along the Gulf Coast. But the intensity of storms and how often they occur has been measurably increasing. And the way hurricanes get their energy is from the heat content of that surface layer of the ocean. So it's not surprising that when you measure that the heat in the oceans has gone up, that you're going to see stronger storms. Next, please. So here's a little bit more of the science. Folks, learn some basic science in school, but here's just the basics of a reminder of the hydrological cycle. Next, please. And just as an example of increased intensity in storms, you get these so-called rain bombs where these increased temperatures just make a storm that's so much more powerful, so much more destructive. And I think it's really a fantastic image. The lighting, I guess, was just right to catch the intensity of this particular rain bomb. Next, please. And then, of course, there's the flooding. So when you warm the oceans, you expand the water. And then when you melt the ice at the poles, you add more water to the oceans. So that means rising sea levels. And when you get these rainstorms and the rising sea levels, you get less ability of water to run off. And this example here is in India, but it's flooding like this has been happening more frequently all around the world. Next, please. So here's some more about the science, about how the temperature increase causes those bigger, more destructive storms. And then, as it mentions at the end, you can also get droughts. So where the water used to transfer through the atmosphere over the land to certain areas can be affected, and it can easily change patterns so that farmers that used to experience enough rainfall no longer get that rain, and they instead get a drought. So you get some areas with increased rain and some areas with less. Next, please. So here's just one more example of where water used to be, and it's greatly diminished at this location in Brazil. Next, please. And I mentioned fires already. Here you can see the correlation. Hotter years typically have more fires. Next, please. And of course, humans get trapped easily because people drive where the roads are. This is a particularly bad fire up in Canada. Next, please. And so here's some statistics just looking at the increase over the last just 4 decades of extreme weather. Next, please. So I mentioned melting glaciers and polar ice. So when that ice is on land, it then, of course, melts into water, and then that transfers into the oceans. And so you can see here that the measurable amount of ice that has existed for a long time in a relatively stable manner has decreased drastically. And this is here just the last 20 years. Next, please. And with those rising seas, places like coastal cities such as Miami Beach, Florida, have found much more flooding, including during just normal tide rises and falls of the ocean level. So there's now roads that just on a regular basis become flooded. Next, please. So of course there's coastal cities all around the world. So here's a listing of the top 10 at risk from sea level rise. Next, please. And by population, you can see the number of people that are going to be affected is quite large. Because there are now more of these mega cities around the world with multiple millions of population. Next, please. Now, of course, U.S. Department of Defense looks forward at what might be affecting them in the future with their mission. And So they're looking at what causes of disruptions around the world, these effects that have already been measured and we know will continue to increase because of the baked in effect of what has already been added to the atmosphere. And they're looking at food, water shortages, and everything that can happen around the world that's undesirable. Next, please. So the growth of food, growing of food is, of course, of utmost importance to humanity. And these changes in conditions are really making a number of crops impossible to grow. Next, please. So, and then of course, on the medical side, increased heat just makes certain diseases explode in their ability to affect villages and human populations around the world. So medical concerns are a great worry. Next, please. So diseases that used to be limited have spread now to greater ranges, affecting more of humanity. So this is particularly worrisome looking map. Next, please. Zika virus, of course, is just one of those diseases. Next, please. And of course, diseases affecting people are one thing, but there's effects on all different types of life. Frogs are particularly susceptible to a number of funguses, and when you up the thermostat, the funguses can be more virulent, and unfortunately that is causing us to risk losing up to, according to this statistic, 50% of all land-based species. Next, please. So here we're looking at the cost of carbon and just all the different ways that it affects us all the way down through the sea level rise. And this is just a limited list. But it is considered the #1 threat to the global economy. Next, please. So the question is, must we change? Next, please. And the answer, of course, is yes, we must. We cannot continue to treat the atmosphere like an open sewer. Next, please. So the second part, can we change? So I'll continue on into this, and at some point, Douglas, then we'll switch and we'll let you continue, but I'll try to go like halfway through these. So this question, can we change? Next, please. And we do know that we have the solutions in hand. We've looked at what we're doing and we know that we have solutions. Next, please. For example, with green energy production, that is renewable or sustainable energy production, we had a projection in 2000 for wind capacity in particular, and that's measured in gigawatts of output from the wind turbines. And one particular projection in 2010 or 2000 by 2010 was that we would have 30 gigawatts of wind being turned into electricity by wind turbines. And the reality we found is that by 2019, not only had we exceeded that 30 gigawatt, but we had exceeded it by a factor of 22. So we do have this as a solution. Wind power is a very viable solution. Instead of burning fossil fuels to make electricity, we can make electricity with wind turbines. Next, please. And this is just showing how much actually has already been put in. We need to put in many more wind turbines, but this graph shows what has been accomplished to date. Next, please. So globally, wind can supply worldwide electricity consumption 40 times over. So there's many good wind locations, and we're just starting to tap that. And wind alone is a very viable solution because the known locations where there is a good wind resource have been measured. Next, please. And then on the solar energy side, kind of similar, the projection and the reality. So there was a projection, and yeah, it just keeps getting better in the reality side. So the 1 gigawatt per year by 2010 projection has been exceeded now, or as of a couple of years ago, the latest data, by 121 times. So not only is wind a viable solution, but solar is as well. Next, please. And also, I love this hockey stick type of graph. It shows how very slow at the beginning because the cost of solar made it non-competitive. And now that solar is competitive, it just has taken off. Next, please. And I just love looking at this. It goes all the way back to 1976 with a really high cost, and the engineers have just set the goal of bringing those costs down, and now you can see it's way down. Next, please. See it coming in slowly here on my screen. Okay, so solar, of course, it's great that it can be deployed almost anywhere in the world, no matter what kind of housing structure you have. Of course, not shading it is always advantageous to the efficiency of the cells, how much power they can put out. And so now that people all around the world are able to communicate with cell phones and things like this, you need to be able to charge those cell phones. So even though it may seem insignificant, one small solar panel like this can really improve the lives of people in remote areas of the world greatly. Next, please. And I love how this chart builds. It's going and going and going and going and still going. Yeah. This really shows you how solar has grown. And this happens to be the market in Chile in South America. Next, please. So, and this is a little similar to that early chart, but it just goes to show you how the amount of sun, if we use solar panels, is more than enough to meet humanity's electricity needs. So wind and solar together are definitely solutions. Next, please. And then, of course, we need to talk about storage of electricity, because we all know that solar and wind are intermittent resources. So this gets us onto the topic of storage. Next, please. And then the efficient use of electricity is of great importance. And it's been a revolution in lighting since LED lights have become common. They are so much more efficient than incandescent lights that the electricity that is produced with renewable resources can be used much more efficiently. Next, please. And of course, the topic near and dear to my heart is EVs, electric vehicles. So more and more manufacturers have seen the light, and they realize that the advantages of electric vehicles, the fact that they do not require us to pump fossil fuels out of the ground and take that long stored carbon and dump it into the atmosphere, EVs are able to use the renewable electricity from solar and wind And these manufacturers have seen that that's the way to go. Next, please. So can we change is our next question. Next, please. And of course, the answer is yes. So as I mentioned, I'm in an electric vehicle right now. So next, please. And the third, will we change? So at this point, Douglas, would you like to go through the remaining slides?
Let's see, can you hear me now?
Yes, I can hear you.
Okay, thank you very much for doing the narration on those slides. The Paris Agreement was in 2015. And in 2017, the People's Climate March in Washington, D.C. turned out a very, very big crowd in a very, very historic place. Voices, votes, and choices. Join us. Voice, vote, and choice. Use them. Speak truth to power. Like your world depends on it. Your world depends on it. We added one more chart. It's one that I added. And by the way, there's a famous book and a famous movie. We added one more chart of our own. I looked around environmental justice resources with the Climate Reality intranet. Environmental justice and climate justice, I found a link called White Supremacy, Then and Now, which led to a resource, the Poor People's Campaign Arts and Culture page. So Climate Reality Project links to the Poor People's Campaign. And I really, really enjoyed this song with a music video here. Just this 60 seconds, I'm just going to play less than a minute. I'm going to advance, if I can, to 55 seconds here. They start the song at about 55 seconds, and then it lasts for just a minute.
Douglas, I don't hear a song.
Okay, let's see. What I think I need to do is stop sharing and then share again with an option selected so that you can hear the sound. So I'll stop sharing and then share my screen again. And yeah, here we go. Share the sound. Thank you, Svetlana. It's really important to hear the sound on this one. It says I need to install a Zoom audio device. So I hope that's not really true. Let me try again. Could you hear that?
Nope, not on my side.
Well, I'm not going to take the time to go install a Zoom audio device here on my computer, but I'll put the link in the chat. And it's a really, really great song from 1968. And they gave it an update, a little rap beat. So like I say, I'll put the link in the chat, and that concludes our presentation.
What's the name of the song, Doug?
The name of the song is Everybody's Got a Right to Live.
I think that's what displayed on the screen right now, Charles.
Okay, got it.
Yeah, when you get to that page, it's the one at the bottom there, and it has that song title in it.
Yeah, I see that, right.
When can we start asking questions?
I think now.
Okay. I'll go first.
Go ahead.
I'm ready. Yep.
First question for Dave. On one of your first slides, Dave, you showed that from all the sources, we're dumping 152 million tons of carbon products into the atmosphere every day, every 24 hours. And they comes from all sources, forest fires, coal burning, airplanes, everything else. But you didn't mention how many of those tons, or what's the proportion of those products that are washed out of the atmosphere every day. Is there a number for that?
I'm sure there is a number for it because yes, the oceans do absorb quite a bit of the CO2. In fact, they found that there's increased ocean acidification in places, for example, on the northwest coast of the US, the Washington State and Oregon coasts, where they try to grow shellfish. The ocean acidification has increased so much that the small fry no longer can form shells because that depends on the pH of the water greatly. So that, yes, there have been a number of measurements made. That would have actually been good to have that in the slide already, is what is the amount that comes out as well every 24 hours, as well as the amount that goes in. But we do know that the net number is still more going in than what comes out of the atmosphere.
Yeah, I would imagine it would be. But then there's the upper atmosphere and the lower atmosphere, and the products in the lower atmosphere, I think, get washed out by rain. Or that's the question: how much gets washed out by rain, and how much is left to go into the upper atmosphere, or can those products even get into the upper atmosphere? And so that's a question too. I don't know if there is an answer to that.
I believe that the atmosphere tends to mix a lot more. The oceans tend to get stratified by temperature. And so the surface of the ocean is much warmer than the deep ocean. As far as things like CO2, it mixes, I believe, between the lower and upper atmosphere. You're right that the rain, of course, can only affect things in the lower atmosphere. But yeah, those are more good data points that maybe in future slides we can get.
Well, also, I forget how many tons, but there are tons of material that are added to the Earth from meteors coming in from the solar system and from the galaxy that come into the atmosphere every day. Matter of fact, that's what causes rain, because in the upper atmosphere, those decaying meteors from burning out become condensation nuclei, in which they attract moisture around them, and that causes them to drop from the atmosphere into the ground. That's rain. And so I don't know what the, I forgot what the tonnage is of those, but it's amazing how much tonnage comes in from to the upper atmosphere. But that leads me to, go ahead.
I was just going to say, yeah, there's a number of natural effects. As you say, material gets added to the Earth, on a daily basis, a constant ongoing basis. In the same way that materials get recycled by volcanoes and so forth, when you have the tectonic plates move, it creates friction and heat, and it melts rocks underground, and those spew up not only rocks, but trap CO2 and so forth. So yeah, there's been measurements made of what is happening as part of natural processes, and then also what has been happening since the Industrial Revolution in terms of people's effects. Yeah.
Right, and that leads me to my last question, and that is to separate the people's effects from the natural cycles of that causes weather change and causes climate change. There's a short-term cycle, a mid-term cycle, and a very long-term cycle that climate change happens, and that causes temperatures to fluctuate in those cycles. And so I think it would be very advantageous to have data that shows those changes in the natural cycles that happen without man's interaction, and then show mankind or human interaction that changes that. And that would be very convincing to show the human effect, I think, because I think too often I hear arguments against climate change due to man, that it's all natural, and some is due to human effects, but not that much, and it's all in the noise, they say. So I still haven't seen much data on the separation between the natural effects of change and the human effects of change. That would be good to show, if it can be shown at all, if it is even known.
Right. No, I agree with you. This set of slides is actually a greatly reduced set of slides in order to keep the time frame to a reasonable amount of time to be able to show them. I have seen a much bigger set of slides, and I'll review those to see where they've actually distinguished the human-induced changes versus the natural cycles. It is very well known, for example, with the CO2 per year, because there's more land mass and therefore more plants growing in the northern hemisphere than the southern hemisphere. On an annual basis, you get CO2 does kind of a little dance. It goes up and down every year because as plants grow in the northern hemisphere more so than in the southern, you get a slight reduction in CO2, but then during the rest of the year, you get an even bigger growth in CO2, such that year after year after year, it's caused that number to rise from about 250 parts per million in the pre-1750. I think that's usually the year they say that the Industrial Revolution kind of started, when people really started burning coal in much greater amounts than prior to that. Prior to that, people burned a lot of wood, which of course went through a natural cycle of burning the wood goes in the atmosphere, and then trees regrow on the land where you would cut them down. And so once the coal started coming out of the ground and being burned around 1750, that's when the quantity of CO2, when averaged over years, because as I say, each year has got its own little dance of cycle, that it's increased from that 250 parts per million up to currently over 400 parts per million. And so the bigger set of slides I know shows things like that, but also, as you say, the other types of effects. The one thing I really kind of want to caution against is just trying to wish away the human effects. Yes, there are natural effects, but yeah, the measurements have been such that humans are beginning to overwhelm the natural cycles. We just have so many people on the earth, and everybody wants to live the same kind of lifestyle that we do here in the US, with convenient transportation and eating the food we want and throwing away the rest of the food. So a lot of food waste causes things to be dumped into the atmosphere, because food eventually that's not eaten, it rots and becomes CO2 and goes into the atmosphere. So yeah, our human effects have just begun to overwhelm the natural ability of the earth to sustain itself and to just replenish things. But yeah, exactly, those statistics need to be brought out to show the difference between the human effects. And as I say, wishing away undesirable effects is not going to make them go away. As Upton Sinclair said, trying to make a man understand something that his paycheck depends on him not understanding is a very difficult thing to do. So yeah, there's lots of people that just kind of would wish these human effects weren't there, but the measurements show that they are there.
And a few quick comments. AIAA jumped on board the United Nations goals all of a sudden in a very quiet way in April of 2021. That's very late, but climate is a very important subject for AIAA, and the leadership is totally on board with the United Nations goals. We prepared these charts, this presentation, three of us, for AIAA Houston Section Annual Technical Symposium for today. And the Johnson Space Center director was our keynote speaker. But once we moved the event from Wednesday to Saturday, she gave us recorded comments, instead of coming in person. And we only had a few abstracts for today, so we postponed the annual technical symposium until until March, a Saturday in March. But it's really, really good to be able to present these charts on the subject of climate here at such a prestigious event, even if it is a small event.
I know
Douglas, we have
that,
hold on, Mike, please.
okay.
We have Charles that holding his hand. He wanted to ask a question.
Yeah, thanks, Svetlana. I have a question and a comment. You know, one of the things that struck me so much on those charts was, I think on the CO2 emissions, you know, I was trying to gauge visually, but I think over the last 25 years, we've doubled the number of CO2 emissions, which is just incredible given the span of that chart. But I guess the question that I have is, I'm on my way to a Mach-E, which my new goal is by January 1, so I'll report back. And Ellen, you know, I'm always amazed at Ellen's solar power and the stories there. So that's a goal as well. But beyond those two, what are the things that we can actually do as individuals to have the most impact on reducing the emissions and protecting the environment?
So if I can go first, Douglas, what I would say is getting representatives in our Congress who realize the benefits of sustainable energy. Texas is now more than 18% wind power on the grid. So kind of automatically, when you plug in your toaster and toast your toast in the morning, just on average is 18% of the electricity being used by the toaster is already Texas wind power. And I believe Texas is now up to 2 or 3% solar power. So a certain amount on individual rooftops, but also a great deal of utility solar has been put in Texas, just because we have the land area and it's just become so efficient now. So industry is tending to move. I mean, people could always wish it would move faster, but industry is already tending to move towards sustainable energy. It tends to provide more employment than extracting fossil fuels does, and they're higher quality jobs, wind turbine technician and so forth. They put in very high safety standards, so they're not as dangerous as those roughneck jobs that have been in Texas for many decades, over 100 years. The thing that we need now are things more like transmission. And already in this infrastructure bill that I alluded to earlier that should be signed on Monday, are a number of billions of dollars for transmission, because you can produce the electricity in good areas, but if you don't get it to where the people live in the urban areas, it doesn't do you any good. And from what I've read, the number of billions of dollars for transmission, they say, yeah, it's a good start, but we need a lot more transmission to get that clean electricity to where people are. But in order to get bills like that passed, we need representatives in the US House and Senate and in the state houses who believe that we should limit our burning of fossil fuels and move more to sustainable energy. So I'd say the number one thing is try to get people who are like-minded with you into those elected positions. On top of that, of course, you can, in Texas, in many places, choose your electricity provider. Some actually advertise that they're 100% wind and solar energy. There's pluses and minuses to that side of things. And of course, putting solar on your own roof is a viable option for a number of people, not everyone. As I said, utility solar, I think, is going to end up being much bigger because there's so many people that live in apartments and so forth. There's just not enough roof area there. But those are a couple of the ideas.
Yeah, and Dave, you did have one slide that shows the storage of energy has gone up over the years. And I think that's the other problem, not only transmission of electricity, but storage of energy. You can produce a lot of energy in the sun in the daylight, but then you have to store that for use in nighttime, and probably some also for wind, not as much as solar. But so I think that technology and the advances in storing energy are continuing to increase, and that's going to help a lot in the future.
Yes, I agree with you. And it's something that we've seen, and particularly because I've talked about EVs, that battery technology is advancing rapidly, and building of battery factories all around the world is advancing very rapidly. And those same batteries not only can go into EVs, they can go into stationary storage. And it was really kind of interesting. I went to a Houston Renewable Energy Group meeting over a year ago, probably over 2 years ago, because it was pre-pandemic. And the speaker was a guy who worked with real estate purchases. And I thought, well, gee, somebody, real estate and the Houston Renewable Energy Group. So what he said really astounded me, that one of the most popular places for investors to buy small parcels of land, like 1 acre or so, is next to electrical substations. And what they were preparing for was this big production of batteries from these new factories. And the batteries would be located next to the substation, and then it would be used for arbitrage of electricity. In other words, buy low, sell high. And so I thought that was so interesting. And I really wasn't expecting somebody to talk about real estate investment, but that was his business. He wasn't trying to get anybody. He was just an invited speaker, and he came and spoke for free and told us what was happening in his industry. But it just really shows how there are a number of forward-looking people around the country, and they could see that, you know, more batteries are going to be built, and the difference in demand of electricity during the times when people are awake and when they're asleep is so great that that stationary storage is going to be needed, because yeah, when the wind blows at night, but people aren't running their toasters much, it really is very practical to store it into batteries and use it the next day.
Thanks, everybody. I need to run to another appointment. I'll see you soon, I hope.
Thank you,
Thanks so
Doug.
much, Douglas.
Thanks a lot, Doug.
Yeah, thank you, Douglas.
Thanks,
And
Doug.
thank you, thank you, Dave, for a presentation. And I wanted to echo what Dave had mentioned before as a response to Mike's question. Yes, the if there's numbers, if there's data, it's definitely much easier to convince other people that there is truly impact from humans onto the climate and devastating effect. But a lot of people are, or a lot of a lot of people are basically hiding behind that, not knowing exactly the impact. We do know that there is some impact, but we don't know how much, and therefore we're not convinced, right? And that is one of those inconvenient truths, I guess. And that's what we essentially need to agree to, or at least continue to figure out how to get out of the this overwhelming the factual information that still keeps coming in, and of course the research and the gathering of the facts is taking place, or will take time. It doesn't happen overnight. And so the misfortunate for climate is that while we're trying to convince ourselves that it is indeed us that are responsible for it, and we have to change our behavior, or we will have to change our consumption level or type of consumption. And in meantime, the damage still continues ongoing, and hopefully we are not going to get to the point that of no return, but I think we're getting close to it. And unfortunately, we are losing a lot of natural landmarks that are not just children, but our children's children, and probably some of those even us will never experience ever again. Like one of them that I can think of is the Great Barrier Reef, is this completely being bleached out and disintegrating, and that's one of the natural phenomena that is amazing and yet is impossible to save. And that's that's difficult. That's difficult to understand, to comprehend for that. Wow, this is how much we polluted that we no longer can roll back from the changes. Well, thank you so much.
In reply to Charles' question in the chat there, I saw the quote again yesterday, but I'd seen the Upton Sinclair quote and heard it over the years for a long time. So I just keep that in my head in answer to your question.
Yeah, I appreciate the answer, and I appreciate actually, it's a great Saturday morning. It's like adding a little bit of spice to the presentation to have the quote from Upton Sinclair. So thanks.
Sure thing.
Well,
yep.
Yeah, thank you everyone for attending. Thank you, Dave, and thanks Douglas for presenting. I think we need this a little spice up of the reality in our lives to just get back the perspective that it's and both that the effects of our actions, and also that there's some or a lot of progress is being made throughout the years with the development and deployment of both the wind power generation and the solar, and that to me it's always kind of a no-brainer, especially with the solar, that it's the resource that we get for essentially for free, that our Earth, our planet, is getting it from the atmosphere. So harvesting it should be one of the goals, and we can use it and without effect to the environment, because all the others, even renewable like hydro energy from water, we still have to damage our environment to some degree, because we have to build dams and in order to generate, in order to harvest that energy. But with the solar, the benefits are definitely amazing. So
and one of the interesting things with solar, I went out in Colorado. There's a agrovoltaic test going on where you can grow crops under and between the solar arrays when you put them out in fields. And I thought that's really great. And one of the things that they found, there are certain types of plants, they grow well in Colorado, but they've traditionally needed some kind of netting over them to shade them partly, because the sun can get too strong. And so if you can combine those varieties of food plants with the photovoltaics, you get agrivoltaics that can be a double use of the land. And I thought that was really interesting research. And I'd just like to mention, Charles, I actually got the exact quote and stuck it in the chat there. So I always had a problem getting the quote words quite right. So the actual words are in the chat right now from Upton Sinclair.
Yeah, Dave, Catalina, I think, has a question. And
okay.
Charles left, unfortunately, but
okay.
I think he saw it and he thanked you for it.
Yes,
okay.
Thank you for the quote. I found it also in the net. I think it's a great quote. I just wanted to mention, it's not a question, that we are trying to build up a big project, and I will ask a friend to present it because he's in Purdue. And we have there's a very big project on voltaic energy between the border in Arizona, between Mexico and Arizona, because of the capacity, the solar capacity in the desert. And what you said, Svetlana, is very important. We have to find energy that doesn't use water, because there is a big example of in South Africa where they had the water, but the water was used to produce energy, and then the people didn't get water anymore. So I hope we can present this, because there are many options, and of course photovoltaic is one, and wind energy is the other one, where they don't use the water. That is also, we also need the water, right? Thank you.
Right. Yeah, that's a good comment, Catalina. I didn't mention it today, but I've seen studies that talk about, yeah, you need water for cooling if it's a fossil fuel burning plant or even a nuclear plant. There's been cases where those plants haven't been able to run because of water shortages. But yeah, it's even more critical when people need water, and yet the authorities divert it to the power plants instead. And so, yeah, when you have wind or solar, you don't need water. I mean, a certain amount of water to produce the steel to make the wind turbine and so forth, but vastly less in the way of water demands than when the power plants are running. Yeah.
Another aspect that we don't think a lot or discuss is that the effective, when there's a certain timeline or the lifetime of this installation of whether it's a solar or just pretty much any kind of a energy providing thing that is build it up with just about any other type of generation, the energy generation. If you disassemble it, the effect or it's either impossible to disassemble or the no longer can be used for anything else. Like think about the nuclear plant, right? And at certain point, that nuclear plant no longer will be producing or will be capable of producing energy, but that the footprint of that plant plus additional the zone around it is going to be out of circulation for human use forever. With the solar and wind type of production, if and when that either the technology changes or that the production is no longer up to par, when you decommission with the wind type of generation, you just melt it, with the exception of the wings that the propelling that made out of fiberglass, and that they're just being stored in a certain dump site to wait for the time when they can be repurposed. With the solar, it's even better. With the solar panels, they just simply can be melted and repurposed for either future solar panels or something else. So that when it's taking off the land where they were installed, there is nothing. There is no impact to the land. You can put a new generation of the same type of energy generator or something different, the newer and better, more effective. But it's what I was trying to go into is that there is no impact to the land. The land is still can be in circulation for human use, for beneficial use. Not the same for pretty much any other type of generation.
Well, Svetlana, that's true in today's world, where we only have 7.5 billion people, but we have much land that's just sitting there and not being used at all. Just go around the West and you'll see plenty of land that's just sitting there. I own some land in the Mojave Desert, and I can attest to that. But in the future, there'll be more people on the Earth, perhaps, most likely, and land will be there's only so much land, and so we have to use it more and more judiciously. Plus, we in the space business should be pushing very hard to get solar energy from space, which has a lot more land, quote unquote, than the Earth has. And all we need to do is find out how to transition that, transfer that energy down to the Earth without burning a hole in the atmosphere.
That's true. Yeah. There's some quite I have seen some research going in that space, and we'll see what will happen. This is a great discussion. Thank you so much, everyone, and we'll continue this conversation next time.
Okay, Very good.
Thank you.
Thank you.
Have a great
Thank you.
weekend, everyone.
Okay, good.
Thank you.
Thank you.
Have a great
Thank you.
weekend, everyone.
Okay,
Yep, thanks, bye-bye.
bye.
Enjoy, Dave.
Thanks, yep.